is my pleasure to welcome you to Mobile Warsaw Meetup number 24. Hello. And I would like to give a especially warm welcome to all newcomers who have not been here before. Who hasn't been here before? Raise your hands. Yeah, still happens, not bad. And it is also my pleasure to welcome you to our anniversary meetup. As some of you probably already know this, we have some special stuff for today, as this is our second birthday. Yes, the first thing is right over there behind you, and it's a huge badass cake with our logo, which we will gladly consume during the break. Yes, not yet. And as promised, we also have some additional goodies. Exactly, you might have noticed that we have t-shirts, and this color is a special color for either organizers or speakers, so if you see someone in t-shirt like this, you can be pretty sure he's somehow involved with running Mobile Warsaw. Moreover, we will have a special color for attendees, and I believe we have 5 t-shirts to hand out today. So go grab that guy, because you need to register to get a t-shirt. And also we have, as usual, a JetBrains license. And one more goodie for today. You know what Reveal is? Yep. We do. Who knows? Raise your hands. Not bad. So we also have one license for that. If you don't know what it is, Google it, because it's really cool. And as always, we have official sponsors who are paying for the beer today. And first is, of course, Allegro, so give it up to Allegro for the beers. Our second sponsor, who is also paying for the beers you're drinking, is Mobica, so give it up to Mobica. And last but not least, sponsor who is paying for recording this meetup, because as you probably already know, all meetups will be now recorded and will be available on YouTube. So give it up to El Passion for sponsoring recordings. And as said before, if you want to win one of the goodies we have prepared for today, go find that guy during the break. And I guess now, back to you, Antek.
Hey, so as always, Mobile Warsaw weren't possible if it weren't for you. So as always, we are having a call for speakers. If you have a talk you would like to share, or maybe a flash talk because you don't have such huge topic, please contact us, especially Paweł this time because that's his job. And also, if there is someone who you would like us to find and bring to Mobile Warsaw, also contact us. We are pretty good at making people come to Mobile Warsaw. So, other suggestions, as always, also contact us at hellomobilewarsaw.pl, which is also cool. And have a great meetup. And I think I will now announce the first speaker. That will be Paweł this time, this guy, with his favorite topic about testing. Yeah, we heard that a lot.
So my name is Paweł, and it is my pleasure to invite you for a journey during which we'll learn about behavior-driven development. But before we learn what behavior-driven development is, I'd like us to answer a more profound question, which is, what is a unit test? If you have no prior knowledge to unit testing, the first thing that you'd probably do to learn what unit testing is, you'd probably go to Google, right? And you type unit test and see what pops up. Well, the usual thing that pops up is Wikipedia. So let's take a look what Wikipedia has to say about unit tests. Can you read it? Yeah? So read it. It's pretty cool, sort of, right? If I had no prior knowledge to what unit tests are, after reading this, I'd be like, what? Individual units of source code, modules together with associated control data, usage procedure. What is that? How am I supposed to understand what unit tests are from a definition like this? I would not be able to write a unit test after reading this, for sure. So I'd like to start our journey by finding an answer to that question, what is a unit test? But one that is sort of more friendly to average developer. But before we can do that, we have to find an answer for an even more profound question, which is, what is an app? Who knows? What is an app? What is a definition of an app? I'm looking for sort of a developer-centric definition. I know Maciek knows because he saw this already. But apart from Maciek, who can provide me a definition? Yes? Yeah, so the answer was a program that makes one or more functions for the user, which is maybe not exactly the answer that I was looking for, but very, very close. My definition of an app is a set of behaviors created by programmer and expected by the user. This is quintessence of an app. Of course, there is a lot of additional people who are involved in making an app. Product designers, product owners, QA, UX, UI, lots of people. But ultimately, an app is something that we created and something that is expected by the user. And let that hang in your mind, and I'll say something just a little bit controversial. We programmers have a limited cognition, like all people. We can think that we can understand more, we can learn more, we can learn faster, we can understand more complicated stuff, but in the end, we are just humans, and our cognition is limited. And that means we can't always load all of that code into our memory. Remember that an app is a set of behaviors created by us and expected by the user. But at the same time, it is hundreds of thousands of lines of code that you have to understand and load into your brain when you're modifying your app. And this means that by accident, you can change a behavior in your app. And of course, you can think that I won't make a mistake. My app is pretty simple. But you can have a worse day. You might actually forget about a very, very basic functionality that lies somewhere within your app, and you can modify code which will have bad effects. Now, let's imagine a following scenario. Let's say that this beautifully bluish, I can't see colors, so I don't really know, bluish square with letter A is a component that you're working on. And you need to modify it to adjust for your new awesome feature. But A also depends on component B. So you modify component B and you spin off your release cycle to the App Store or wherever it is that you're releasing the app. And after the cycle has been spun, and after your app has gone to a certain point, it turns out that there was a component C that also depended on B, and now C is broken. Because you changed behavior in your component B, and you did not see that it was required by C as well. And what are the possible scenarios here? What are the possible outcomes? Let's focus on 4 outcomes that are possible for this scenario. First of all, you might actually see that you made a mistake while you've been developing your app. In that case, it's a happy scenario. Nothing happens. You just correct the issue and move along. However, that doesn't happen always. I would even say it's not the usual case. I'd say that the usual case is that you have sort of a QA department. Who has a QA department here? Raise your hands. For the rest of you, you're doomed. Exactly, lucky bastards. So if you have a QA department, then there's a chance your QA will catch that. But remember how much wasted time that is. The QA guy has to find the bug. He has to find a way to reproduce the bug. That it happens, well, say 60 to 70% of the time, because otherwise you just won't be willing to fix it. Then when he finds that, he needs to go to the tracker system that you're using and put a ticket there and write a description for what happens when that bug happens, how to reproduce it, so on and so forth. And then you have to read that description, understand what he wanted to say, and then fix the issue. Now, if that bug was found a few days after you worked on that particular part of the code, then everything is okay, because you still remember the context. But imagine you have to go 3 or 4 months back to the code that you haven't worked on for a very, very long time, and you have to do modifications there. You'll probably won't remember what were the requirements at that time. What was the thing that I was supposed to do? And you might even actually lead to a situation when you fixed C, but you broke A. And this underlines a really complicated problem that affects actually any sort of software development. The problem that preserving behaviors of complex systems is hard. In fact, preserving behaviors of any system at all is quite complicated. Because again, you might have a bad day and you just trip over and you will make a mistake. But fortunately, we programmers, we love to build tools that help us. So we came with a thing that is called unit test. And finally, we have arrived at the definition I wanted to present to you. A unit test is a fail-safe that makes sure behavior of your app is preserved. It is a, mathematically speaking, proof that all components in your app behave as expected. It is that guard that stands by the code and tells you, hey, Paweł, you cannot modify B like that, because something else will break. Now, that sounds like a godsend, right? Like solution to our all problems. Maybe it is, but unfortunately, there is a problem with usual approach to testing. What is the usual approach to testing? What do you think?
What should I test?
I'm not sure what I heard, but from my perspective, it's let's just write test afterwards. That is what I usually hear. And this is so wrong at so many levels. I try to summarize this in 2 points. I hope I did a good job of that. So first of all, if you write test afterwards, you don't have something that is professionally called test harness. Everybody knows what harness is? Oh shit, and my reference just died. Uprząż. Yeah. Good, I could use that. So, the test harness is that guardian that stands by you as you're writing code and tells you, hey, dude, you cannot modify that because something will break. And because you have that harness, you're free to modify anything you want in the code because you will know when something breaks. You can go play with the implementation, you can search for a better solution, being sure at the same time that everything still works. And if you write tests afterwards, you won't have that harness. You won't be safe when modifying the code. So that's one of the main reasons why writing tests afterwards just doesn't work. Second reason is that providing a proof whether a program works, mathematically speaking, is way more complicated after you actually have written the code. Why is that? What's the reason? I'm pretty sure anyone here who ever wanted to write a test for a class that had no tests when it was written found it very, 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 very difficult. Am I right? Was it hard to add tests afterwards? pretty sure it was. Now, the reason is that writing tests sort of enforces a different design of architecture of your app. You'll always arrive at code that is way more modular, has way smaller classes, and has very strictly defined interfaces with very strictly defined dependencies. And if you don't write tests before, you won't arrive at that code. So you'll have to not only write tests afterwards, but you'll have to modify your existing code to adjust it so that it is testable. Programmer should let correctness proof and program grow in hand. You know who this guy was? Edgar Iskra? Yes, exactly. He's quite famous. If you studied anything remotely related to IT, then you should probably know him. He also said another very interesting thing, which is written here, and it's sort of complicated, but the essence of this quotation is that by writing test first and then making it pass, and then writing another test and then making it pass, you're getting a very heuristical way of implementing software at very, very, very small steps. Now, another question for you guys. When was this written? Which year?
60.
Sort of, 72. So this is pretty damn old, right? It's older than I am. And TDD is actually older than we all are. Maybe except for you, Scott. Sorry, I couldn't help myself. So again, back to our heuristical guidance. We write a failing test. We make it pass. We write a failing test. We make it pass. And then we enter a super important stage where we refactor our existing code to make sure it is as simple as possible. And we can freely do that because now we have our testing harness in place and we're free to do any modifications that we want. And that is how test-driven development is born. In test-driven development, you always write test first. Always. No exceptions. If you're not writing test first, you're doing it wrong. Which then is made green by writing new code or refactoring existing code. However, test-driven development is not only adding test first. If you're only adding test first, then you're doing it completely wrong. Test-driven development is a great way to determine how complex your code has become. All you have to do is just listen to what tests have to tell you. Do you have to fake 7 objects to isolate one test? Do you have to inject a fake into a fake into a fake? Does your setup method have 70 lines of code? This always points to an overcomplicated design, and your tests are here to point that out very, very, very clearly. If there was one thing that you'll remember from today's presentation, please let it be this sentence. There is no such thing as untestable behavior. You can test everything. The only thing that is not testable is the code that you write. I'm sorry it sounds so harsh, but it is unfortunately the truth. Everything can be tested, every behavior that comes to your mind. If it's hard for you to write a test, it might be so because it is hard for you to clarify what are the requirements for the object that you're trying to build right now. And if that's the case, then tests will tell you that. And you'll have this great moment when you'll know that I'm not exactly sure what I'm trying to do now. What is the thing that I'm trying to build? And you'll have that great moment when you can back away and maybe think about the design that you're trying to come up with. And again, tests are here to help you and to tell you that. Moreover, by writing tests first, you are also becoming the very first consumer of the API that you just designed, even before it has been implemented. How awesome is that? Not only you have this moment to know that this is gonna be shit, but you have that moment before you actually written it. And it's so awesome because you can see it's shit and you can not write it and change the way you build your code. And that's really great. Is the API that you're building right now hard to test? Well, that probably means it will be hard to consume in the future, or it will be hard to maintain after it has been written. But it sounds like TDD is the answer to all questions. But unfortunately, it's not. And if you ever thought, hey, I'm gonna do TDD, then you probably sat in front of a computer, you created a new class, and then you thought, shit, what should I test? What should I do now? I'm pretty sure there is at least a few people here, that includes me, who had this experience. And that is a problem. What should I test? How can I explain what is the thing that I'm testing right now? How can I clarify my requirements? How can I provide examples? How can I clearly provide examples how my object should behave? This is exactly where behavior-driven development enters the stage, as it builds upon TDD and tries to answer these questions. And in fact, behavior-driven development is really simple, but it requires sort of a shift in how you perceive your test suite. Second thing that I'd like you to remember from this presentation, after the first one, I hope you still remember the first one, is that when you're writing tests, please don't think about tests. If you do so, you're probably already doomed. Think about behaviors. Think about examples, how your object should behave, and how should I write my examples to make assertions about my object's behavior. And your object's behavior is defined by the methods it declares in its interface, as well as sockets that are its dependencies. In Objective-C, of course, these sockets would be properties. And that is the only thing that you should be testing. Only the external interface of your object and how it interacts with its dependencies, or how it uses its dependencies to calculate sets of data. If you're doing anything that is close to internal implementation of your object, then you're probably doomed. And the reason for that is that if you're writing internal tests for internal implementation, then your tests become very, very fragile to change. A perfect scenario for a test suite is where I can exchange whole implementation of my object, not changing the interface and not touching tests. This is, of course, an ideal scenario, which you will not always be able to create, but you should pursue it, and you should try to arrive as closely to it as possible. Moreover, BDD provides an ubiquitous language which helps you understand what are the requirements, and we'll learn about that language in a second. And now, let's move on to an example. Before we actually dive into the example, let me introduce you to some of the tools you will see. You'll see Specta. Who knows Specta? Not bad. Who knows Kiwi? Okay, I still see a subset of people who might not know what's happening, so we'll do a short introduction. Of course, there is Expecta, which comes with Specta, but it's not actually bundled with the software, and we'll use OC Mojito for mocking. So in Specta, you always, always, always have a spec begin macro, which defines a class that is called photo upload view controller. And at the same end, we have a spec end, which just closes that class definition. Then we have something that is called a describe block. Describe block is a syntax sugar that is used for separating certain behaviors. Then we have a before each block, which is used for, well, doing stuff before each test. We have an after, we have an after each block that is used, that is called after each and every test. Then we have a nested describe block, which again has before each, and we have a it block, which is the actual test. Now, the order of execution for this it block will have first our before each block run, then the nested before each here, then our actual test, and then our after each block. If I added a describe block here with before each and a it block, then the order of execution for this it would be this before each, this before each, this before each, and the test itself, and of course the after each block. Is this clear? No? Yes, okay, I hope so. Because you're doomed if you don't understand this at this point. So let's go to our class and see what it actually does, and I really need second hands at this point. Let's do this. Ta-da. So we have a really simple class that is called photo upload view controller, which should be created with an instance of a photo uploader object, and we do that via this designated initializer. In our implementation, in our designated initializer, we create a right bar button item with, of course, a title, style, target, and selector. And in that action, we just call photo uploader, upload photo with some new photo and some random completion. And this is really simple, and you can imagine that this is sort of a scaffolding for your upcoming photo upload view controller. How can we test this? Well, we'll see two approaches. First, that will be fully non-behavior driven, and second, that will be fully behavior driven. Let's start with the bad one, right? So if I have no knowledge about behavior-driven development, I could go with a very naive way of testing this. As we can see here, I just grab my right bar button item. I test its title, whether it is the thing that I actually wanted to set. I see whether my target is set correctly, and whether, and whether my action is what I wanted it to be, which is the aforementioned selector. And for describe block, which tests whether the photo is properly uploaded when the button is tapped, just calls the did tap upload button method, which is exposed in this beautiful private category that we have in specs, and it's just called directly. And then we use OC, and we use OC Mockito for verifying whether that has actually been called. And what is wrong with this example? Well, the problem is that this example is really, really, really close to the implementation of our object. It is quite tied to how our photo upload view controller works, as it expects that our target on this bar button item will be our photo upload view controller. It expects that we have this method defined as action, and it also expects that such a method actually exists. I can easily imagine a scenario when I refactor the name of that method, and it's no longer there. And then you have a problem because your tests fail, and you have to go to your tests and refactor tests as well. And tests should be here to help you. They should not be a burden to you so that you have to go and correct them when you're correcting the code. when you're refactoring the code. So let's take a look at a slightly different approach, which will be, by the way, way simpler. We also have a before each block where we grab our bar button item. We, of course, test whether the title is correct. And then we say when the button is tapped, and we simulate the tapping, which is really simple because we're just using target of the bar button item, perform selector, action of the bar button item with the actual bar button item. And then we assert whether our photo uploader has been called with this specific method. And this implementation of tests doesn't really care what happens under the hood. It only cares about the actual behavior, which is when I tap my right bar button item, I want my photo uploader to receive such a message. And that is how you should always approach your tests. If you try to get them too close to your implementation, you will end up in hell because you'll have to fix the tests all over again, and you probably won't be willing to write them, and you'll be doing test-driven development, well, just wrong. I'm not sure whether we have time for another example. Lucky for you, this is all available online, and you'll be able to go through, I believe, 5 other examples or 4 other examples that I have for you. So let's go back to our presentation. And I lost my presenter notes. Awesome. Now, I'd like to close up by something a little bit different. As you might have thought that test-driven development and behavior-driven development is the answer to all questions. If I start doing behavior-driven development today, I will not have any bugs anymore in my code. Well, unfortunately, that is not true, and if that's what you expected, then I'm sorry. You will have bugs. You just cannot not have bugs. But, having that said, behavior-driven development or test-driven development is a great way to reduce the amount of bugs that you'll have in your app. Moreover, if for some reason there is a bug that slips your test harness, well, you can just write one more test that makes sure that bug never happens again. And you won't have that as a regression bug. And that means that your QA will spend way less time on doing regression testing and will be able to spend way more time on doing exploratory tests so that you'll have a more reliable app that works really good in edge cases. Now, I'd like to close with a really great quotation, one of my favorite ones actually, about testing. That comes from a blog called Agile Warrior, and it's been written for Jonathan Rasmussen actually I should say nearly 3 years ago. And before I show you the quotation, I need to share the context in which it was written, because it's really, really important. Jonathan was wondering, how is it possible that quality of iOS software is so good when testing culture on the platform is so poor? Because if any one of you tried doing testing 3 years ago, then you probably know the landscape was quite poor. And the tools were lacking. Apple didn't really care about testing at all, as there was no XC test, or there was, well, semi-official support. And the quotation is this, and I'd love this to be our closing thing that you'll have in your mind when you leave this place. If you're not writing unit tests, that doesn't mean you'll ship crappy software. You probably won't. But unit tests are a great way for building awesome software and making sure you can speed up your development cycles and deliver more reliable software faster than ever. Thank you for your attention. That would be everything. These are the resources. The first link, you can find the additional examples that I briefly showed you for half a second, as well as other stuff related to test-driven developments. I also encourage you to read Objective-CIO issue number 15, which is fully about testing, to which I also happily contributed an article about behavior-driven development. If you have any questions after the meetup, if any questions pop into your mind after the meetup, you can grab me on Twitter, or that is my email. Feel free to ask, I'll be happy to answer. And I believe now it is time for questions that you have right now, if there are any. Yes?
You said that all code can be tested, but in some tricky situation, for example, random number generation, the tests are far from obvious. Is it always worth to invest so much time to test on the
Well, in case of random number generator is usually part of the OS, not your code. And you should not be testing OS itself, you should be testing how your app interacts with the OS itself.
Yes, but that was example of the code that is hard to test, not exactly the one that I would try to write for the iOS.
Oh yes, but I believe you're not writing OS software itself, right?
No, but there are.
Well, yes, but in 99.9% of cases, it's the code, not the behavior itself. Yes?
Do you write so-called feature tests like if does, or you just BDD controllers?
So the question was whether we're using if tests or feature testing, to be specific. We used to, and after half a year, when I spent about 30 hours or so investigating just random bugs because Skiff couldn't scroll as good as it should and something didn't pop up, we just killed the whole thing. For us, it proved unreliable to a point where it was bringing more burden on us rather than value, so we just killed it off, and we're happy with just having very good test coverage in terms of behavior-driven tests. But I know Kif improved a lot since then, because we used version 0.1 point something, and I believe they have version 3.0 right now. So things might have changed, but we haven't explored the landscape. There was a really cool thing called Subliminal, I believe, but Apple killed it with Xcode 6 as it doesn't work anymore. So if you're writing stuff like that, you're always at risk that Apple will break something. Any other questions?
I have one. So behavior-driven testing is more like testing features, all features, than testing only functions, right, and methods.
Well, it's sort of intersection of both. The question was whether behavior-driven development is more like testing features rather than testing functions. So it's, as said, it's more of a intersection. You're still testing code, but you're trying to focus on testing actual behaviors of components that you have in your code rather than testing individual functions. Because then you can test actually more and have a better coverage and still, well, write less code. Does that answer your question?
Yeah.
Awesome. Any other questions? Yes?
In many cases, project specifications changes frequently, and how can you be sure whether covering whole project in unit tests will be profitable? Because as self-linked, it seems like complete waste of time and resources. Because when, as I said before, when specification changes because client tests.
Could you speak up, because I'm not sure whether I picked the question correctly.
If the project specification changes frequently, like covering project in unit tests seems like waste of money and time.
So the question was whether is it worth to invest in unit tests if your requirements change quickly?
Exactly.
So I'd say if you're doing an exploratory feature, then it might be worth to not do testing initially. But in any other case, when you're writing code that you are at least remotely certain that will make into production, then yes, it is worth investing the time. Because if you have to modify code, it might be so that you have to modify part of the behavior. And if you do not have a test harness in place, you can introduce bugs because of the scope of the refactor. I actually have a good story about this. A long time ago, we introduced core data into one of our apps, and at one point we got to a place where it was all over our project. And it really sucked because we have to push that managed object context everywhere. And we didn't really use it, so we decided, shit, let's get rid of it. Let's get rid of it. And it was in about 80% of classes. We ripped it out, made the app at least compile, and we had from 1,500 tests, we had 800 failures. Next day afternoon, we had no failures, and the app just worked. And I'd like to use that as an example that changing requirements and not writing tests might actually not be a good idea, as you don't have that test harness which will allow you to move quickly. Does that answer your question?
Yes.
Cool. Any other questions? I guess that's everything, so thank you very much, and I guess go for the cake.